Hello, another AQA multi-choice physics question. If you want to try to answer the question yourself, please pause the video now. If you got the answer C, well done. If you didn't and would like to see my explanation, please continue watching. So we have an alternating EMF is induced in a coil rotating in a magnetic field. What is the phase difference between the magnetic flux linkage through the coil and the EMF? So again, we can always turn back to the equations we're given to help us answer these questions. And you're given that the flux linkage, which is the number of turns multiplied by the magnetic flux, is equal to the flux density multiplied by the area of the coil multiplied by the turns in the coil cos theta, where theta is the angle of the coil within the flux. The induced EMF is given by, again, flux density, area of coil, number of turns, and then sine omega t, where omega is the angular velocity of the coil and t is time. Well, the angle at any moment in time is equal to omega t. So the flux linkage is equal to cos theta, the EMF induced is equal to sine theta. So let's just quickly plot those graphs. If I have theta along here, then cos of theta will look like that. And if I have sine theta, it will look like that. Well, the difference between these phases is 90 degrees. 90 degrees is the same as pi over 2 radians. Answer C. Thank you for watching. Please watch more of them. Please subscribe. If there's a particular question you'd like me to go through, please send that request in the comments section. Thank you very much.